Hello everyone, in today's video we are going to cover exponents and division. Our learning target for today is I can simplify expressions using the quotients of powers property. Now looking at exponents and division, the quotient of powers property, this is what happens when we divide like bases. When like bases are being divided, their exponents can be subtracted. So the rule is when I have like bases being divided, I subtract their exponents. In other words, if I have x to the a power divided by x to the b power, we have x to the a minus b. Now, a quotient of powers with the same base can be found by writing the powers in a factored form and dividing out common factors. So we can see here in my example, 3 to the 5th would be 3 times 3 times 3 times 3 times 3, divided by 3 to the 3rd would be 3 times 3 times 3. When I divide, I'm taking out each common factor, so I'm dividing 3 by 3, which would give me 1, 3 by 3, which would give me 1, 3 by 3, which would give me 1, leaving 2 3's in the numerator. And that's 3 squared. Now an easier way to think about this is just 5 minus 3 would be 2. So again, when I divide like bases, I can subtract their exponents. Looking at a few more examples, if I have 2 to the 7th divided by 2 squared, again I'd have 7 2's in my numerator, and then I'd have 2 2's in my denominator. I'd cross off a grouping of 2's, leaving 5 2's in my numerator, which is 2 to the 5th. Again, an easier way to do it, 7 minus 2, 2 to the 5th. If I look at b, I have x to the 4th divided by x to the 3rd, so I'd have 4 x's in my numerator, divided by 3 x's in my denominator, and then I cross off each grouping of 1x in the numerator and 1x in the denominator, leaving 1x in the numerator because 4 minus 3 would be 1, so that's x to the 1st power. Looking at a few examples, we're going to try these. Number 1, I have 3 to the 7th divided by 3 to the 4th. So I'm going to keep my bases the exact same and subtract their exponents. So 3 to the 7th divided by 3 to the 4th, I would have 7 3's in my numerator, 4 3's in my denominator. If I were to cross these off, I would be left with 3 3's in my numerator. So this is 3 to the 3rd power because 7 minus 4 is 3. Number 2, 5 to the 12th divided by 5 to the 8th is 5 to the 4th. 12 minus 8 is 4. Number 3, 4 to the 6th divided by 4 to the 10th. Here I would have 6 minus 10, which is negative 4. I don't have negative exponents in my answer, so I would leave this as 1 over 4 to the 4th. Because if I think about when I subtract this, I would have the 4's in my denominator because 6 in my numerator, 10 in my denominator, leaving 4 4's in my denominator. So 1 over 4 to the 4th is number 3. Number 4, 9 to the 3rd divided by 9. 3 minus 1 is 2, so this is 9 squared. 5, we now have variables. We're going to keep the same exact thing we did if the base was just a number. So remember, the variable is a base. So a to the 8th divided by a squared. 8 minus 2 would be a to the 6th power. Number 6, r squared divided by r to the 7th. 2 minus 7 is negative 5, so the 5 would be in the denominator. So I'd have 1 over r to the 5th. 7, z to the 9th divided by z. 9 minus 1 would be 8, so z to the 8th power. And 8, w12 divided by w15. 12 minus 15 is negative 3, so I would have the 3 in my denominator. So I'd have 1 over w to the 3rd. Number 9, now I'm adding in a coefficient. So I have a coefficient as well as a variable. So here I have 8x to the 7th divided by 2x cubed. How I want to treat this is I want to treat my coefficients together and then my variables together. So this is a division problem. So I divide 8 by 2. 8 divided by 2 is 4. Now I look at my variables. X to the 7th divided by x cubed would be x to the 4th. So 8x to the 7th divided by 2x cubed is 4x to the 4th. Number 10, 3x to the 4th divided by 9x to the 3rd. Again, I'll treat the 3 and the 9 together, and then the x to the 4th divided by x to the 3 together. So 3 over 9 is 1/3, and then x4 divided by x3 is x1. So I'd have 1x divided by 3. Number 11, 10x squared y4 divided by 5x cubed y squared. So again, I'm going to do 10 divided by 5, and then x2 divided by x3, and y4 divided by y2. 10 divided by 5 is 2. X2 divided by x3 would be x1 in my denominator, and then y4 divided by y2 would be y squared in my numerator, so I'd have 2y squared divided by x. And then last one, number 12, 4k to the fourth p to the fifth divided by 18k squared p. So 4 divided by 18 is 2 over 9, so 2 ninths. K4 divided by k squared would be k2 in the numerator, and then p5 divided by p would be p4 in my numerator. So I'd have 2k squared p to the fourth divided by 9. In today's lesson, we learned when dividing exponents with the same base, we keep the base the same and subtract their exponents. That's a wrap on today's video. We'll see you in the next one.